Okay, picture this. You're sitting in the exam hall. The clock is relentlessly ticking down. You turn the page and boom, there it is. A massive 15-mark Cambridge computer science past paper question, right off the 0417 or 9626 syllabus, asking you to critically evaluate system maintenance for a complex legacy database. Welcome to this Strategy Explainer. Today, we're taking on the mindset of the sculptor. Think about it. What does a master sculptor actually do? They start with a giant, overwhelming block of stone, and they systematically chip away everything that is totally irrelevant until the masterpiece underneath is revealed. That is exactly the mentality you need to master your Cambridge exams. We're going to look at a real scenario today where two students, let's call them Alex and Sam, are facing down this exact high-pressure challenge. Let's see how they handle it and, more importantly, how you can do it perfectly.
So, you might be wondering, why do so many smart students find applying perfective, adaptive, preventative, and corrective maintenance to unfamiliar contexts so incredibly hard? Honestly, on the surface, the definitions seem like child's play when you're just casually reading them out of a textbook. But here's the reality check. Cambridge examiners are never just going to ask you for a simple, rote dictionary definition. No way. They're going to throw a convoluted, messy, real-world business scenario at you. Maybe it's a global shipping company that just updated its entire logistics software suite. Then they'll ask you to critically evaluate exactly which maintenance strategies are required and why. The sheer difficulty lies in the application. Students just completely freeze up because they haven't practiced bridging that massive gap between textbook theory and practical, context-driven analysis. They know the vocabulary, sure, but they have absolutely no idea how to wield those words as analytical tools.
Here is our roadmap to completely mastering this topic today. First, the maintenance trap. Second, our core definitions. Third, the highly effective method mark strategy. Fourth, specific examiner warnings. And finally, mastering critical analysis. Let's jump right in. Section 1, the maintenance trap. Let's look directly at the specific pitfalls students stumble into when the exam pressure is on.
I want you to imagine a dynamic split screen right in front of you. The timer is brutally ticking down. Both Alex and Sam are staring at the exact same past paper question. It's about a retail company that just upgraded its point-of-sale terminals, but they're actively losing money because the new software keeps crashing. Plus, management suddenly wants to add a brand new loyalty points feature. It is a highly complex problem. Now, look at Alex's approach. Alex starts wildly chipping away, overloading the paper with raw computer science facts. It is a massive brain dump of every single thing they've ever memorized about hardware and software maintenance. Sure, the terminology is impressive, but there's absolutely zero analysis of the specific retail context. Then, on the other side, we have Sam. Sam completely panics, rushes the answer, and totally misses the command words. Sam just scribbles down a quick paragraph that completely ignores the command word evaluate. By missing those specific computer science assessment objectives, Sam is leaving a ridiculous amount of marks on the table. Neither of them is revealing the masterpiece. Both are failing the sculptor's test. And honestly, you don't just have to take my word for it. This brilliantly illustrates exactly what the principal examiner reports warn us about year after year. They specifically state, candidates consistently confuse key terminology, always define terms before using them in extended responses. Look, if you do not define your terminology right out of the gate, your entire analytical foundation simply crumbles. You literally cannot build a high-scoring multi-mark argument if the examiner isn't absolutely convinced that you understand the basic building blocks of your own answer. If you drop the word corrective into your paragraph, you must demonstrate precisely what that means before you try applying it to the scenario. It's a remarkably simple step, but skipping it, that is the absolute fastest way to cap your grade.
Section 2, core definitions. Let's establish our foundation and clearly distinguish between the 4 distinct types of system maintenance. Think of these 4 definitions as the different, highly specialized chisels in your sculptor's toolkit. You need to know exactly which tool to pick up depending on the shape of the problem in front of you. First up is perfective maintenance. This is all about taking an already functioning system and making it even better through enhancements and new features. Imagine a mobile app that works flawlessly, not a single glitch, but the users are constantly requesting a dark mode, or the developers realize they can tweak the back-end search algorithm so it runs 20% faster. The system isn't broken, but it can be perfected. In an exam scenario, whether you're sitting for the 0478, 2210, or 9626 syllabus, if you read phrases like, users requested an upgrade, or the company wants to improve processing speeds, your mind should immediately lock onto perfective maintenance. It is an evolution of a stable system to meet new, much higher standards. Next up, we have adaptive maintenance. This happens when the system's external environment fundamentally changes and the software is suddenly forced to adapt just to survive. It's kind of like a chameleon having to change its colors to match an entirely new background. Let's say a business decides to upgrade every single office computer from a legacy operating system to the absolute latest version of Windows. The custom in-house software they've been using might suddenly start throwing compatibility errors. Or consider a situation where completely new tax laws are passed by the government. The company's accounting software didn't suddenly develop a bug. The world around it changed. The system must be adapted to remain functional within these new hardware, software, or regulatory environments. Then we have preventative maintenance. This is your absolute proactive shield. It involves updating systems to intercept and stop potential future faults before they ever even happen. This is the ultimate prevention is better than cure approach in computer science. Imagine a company server that is slowly, quietly filling up its hard drive with massive log files. Right now, today, it's totally fine. But in 3 months, it's going to hit capacity and completely crash. Writing an automated script to regularly clear out those old files is preventative maintenance. Similarly, proactively updating your antivirus definitions or patching a newly discovered network vulnerability before a malicious actor can exploit it falls right into this bucket. If your exam scenario mentions conducting a security audit, replacing aging hardware right before its expected end of life, or future-proofing a network infrastructure, you are looking squarely at preventative maintenance. Finally, we have corrective maintenance. Now, unlike the others, this is strictly reactive. It is the necessary process of fixing bugs or errors that unfortunately slipped through the testing phase and made it into the live implementation. Look, no matter how much rigorous beta testing a software development team does, end users will always find a remarkably creative way to break things in the real world. If a user clicks a highly specific combination of buttons and the entire application just instantly crashes, that is a defined fault. The process of going back into the source code, hunting down that specific logical error, and deploying a patch so the software functions as it was originally intended, that is corrective maintenance. In your exams, keep your eyes peeled for keywords like system crashes, incorrect calculations, or users reported critical errors. That is your undeniable cue to pick up the corrective chisel. Section 3, the method mark strategy. Now that we have the definitions, let's look at how top-tier students actually structure their answers. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, here is the brutal truth. Knowing the core facts is maybe 20% of the battle. The other 80% is precisely how you package and present those facts to the examiner. Examiners award precious method marks for demonstrating a highly logical, structured process of reasoning. By strictly using the Peel framework, point, evidence, explanation, link, you align yourself perfectly with the exact sequence they are looking for. Watch this. Your point clearly states the strategy. The company requires corrective maintenance. Next, your evidence extracts the data. This is because the scenario states the new payroll system is actively calculating employee salaries incorrectly. Then your explanation applies the computer science principle. Corrective maintenance involves modifying software to fix logical errors that were not discovered during initial testing, which directly addresses this calculation bug. Finally, the link verifies and ties it back to the business. Therefore, implementing this code fix will restore accurate payroll processing and prevent further financial disputes for the business. Boom. It is clean, it is incredibly logical, and it literally forces the examiner to hand over maximum marks. Stop scrolling! Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Welcome to the transformation phase. When you sit down to tackle a massive question, you cannot just start blindly writing. You absolutely must follow this systematic blueprint. First, deconstruct the question. What is the command word? Second, extract the relevant data. If you are looking at a complex data log showing error spikes right after a mandatory OS update, you extract that exact correlation. Third, select your analytical framework. In that OS update scenario, an environmental change strongly points to adaptive maintenance, right? Fourth, execute your PEL paragraph with incredibly clear notation. And finally, present it using the exact, precise terminology we just locked down. This 5-step systematic process is your absolute safety net. When the exam anxiety spikes, this blueprint will catch you.
Section 4, Top Examiner Warnings. Even with a brilliant framework, you still need to navigate the minefields.
Listen, the Cambridge Principal Examiner reports are essentially legal cheat codes telling you exactly what not to do. We've meticulously analyzed years of these reports across multiple syllabuses, and we've found the most critical patterns of failure. There are exactly 3 major pitfalls that consistently, and I mean consistently, cost candidates a top-tier grade. Just by being aware of these 3 specific traps, you are instantly elevating yourself above a massive portion of the candidate pool. Let's do a little interactive challenge here. Imagine a 60-second timer is ticking right now. Here are the 3 top mistakes examiners flag: applying the wrong maintenance type, ignoring the required format, and failing to link answers to the specific scenario provided. Let's break them down. Pitfall 1, using the wrong approach. If the prompt clearly says the government changed global shipping tax laws and you suggest Perfective maintenance because it improves the system, you get 0 marks. 0. It's adaptive because the external regulatory environment shifted. Pitfall 2, formatting. If the command asks for an evaluative report and you quickly jot down a few bullet points, you immediately lose all presentation marks. Always respect the requested format. Pitfall 3, and this is the absolute biggest one, writing generic floating answers. If you just write, corrective maintenance fixes bugs, that is a lovely textbook definition, but it earns you nothing here. You must anchor it. Corrective maintenance is required to fix the specific memory leak bug causing the point-of-sale terminals to freeze during credit card transactions. Context is literally everything. Let's do another quick drill. I need you to commit this memory hack to your brain right now. PAPC. Perfective, adaptive, preventative, corrective. When you are sitting in that exam hall and you flip to a 16.10 maintenance question, your very first move should be to lightly write PAPC in the margin of your paper. Don't even think about it. Just write it. Then, as you read through the dense, convoluted business scenario, physically tick the letters that apply. Are the users desperately asking for a new feature? Tick P. Has the physical server hardware changed? Tick A. Are the network admins worried about future security exploits? Tick P for preventative. Is a live database currently crashing and burning? Tick C. This memory hack acts as your cognitive anchor. It ensures you systematically evaluate all 4 possibilities before you even attempt to write your first Peel paragraph. Section 5, Mastering Critical Analysis. To truly act like the sculptor and reveal the masterpiece, we have to push into higher-order thinking. Look closely at this table. It brilliantly illustrates the massive jump from basic descriptive answers all the way up to the elite evaluative level. At the descriptive level, your focus is just what it is. You are defining terms. Corrective maintenance fixes bugs. Fine, but extremely basic. At the analytical level, your focus shifts to how it works. You start identifying limits. Corrective maintenance fixes the immediate bug, but it requires system downtime, which severely limits daytime business operations. Okay, much better. But here is where the magic happens. At the evaluative level, your focus is why it matters. You actually justify business choices. While corrective maintenance causes temporary downtime, it must be prioritized over Perfective enhancements right now because the current database bug is actively causing daily financial losses for the logistics firm. Do you see that huge difference? True evaluation requires you to weigh conflicting options against each other and make a highly justified, mature business recommendation. That is what Cambridge examiners are practically begging to see. For ultimate, top-tier problem solving, you need to always rely on the deconstruct, solve, evaluate method. This ensures every single conclusion you draw is backed by unshakable evidence. Let's look at this in action. Step 1. You deconstruct the given information, aggressively highlight the key constraints, the specific user requirements, and the rigid technical specifications buried in the exam prompt. Step 2. You solve systematically. Use that pop margin hack we just talked about and deploy your PEL paragraph structure to build an impenetrable logical argument step by step. And finally, step 3, and so many people skip this, evaluate for reasonableness. Take a breath, read your final recommendation, and ask yourself, does this actually make sense for real-world business? If your proposed software solution costs $2 million and causes a full month of downtime just to fix a minor graphical glitch on a website, that is not a reasonable evaluation. Your answers must always be anchored in practical commercial reality. We're bringing it all together now into the final system. If you strictly stick to these 3 absolute rules, you will guarantee analytical depth whether you are sitting the 9618, the 9626, or any other Cambridge IT paper. Rule 1. Command word decoding. Literally never start writing until you've actively decoded whether the question says identify, describe, explain, or evaluate. They demand completely different answers. Rule 2, Peel Framework Application. Relentlessly use point, evidence, explanation, and link to perfectly structure every single extended response. Rule 3, the Time Management Matrix. Please do not spend 15 precious minutes writing a beautifully crafted, highly evaluative essay for a question that is only worth 4 measly marks. Look at the mark allocation, quickly calculate your time, and allocate your effort proportionally. These 3 rules form your complete, foolproof system for exam mastery. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. It takes real, dedicated practice to successfully map theoretical textbook knowledge onto messy, practical business scenarios. But the complete blueprint is right here for you to follow. So, here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now at acetheexams_IGCE and click that bell. Don't let another exam pass you by. Because ultimately, applying these exact concepts to totally unfamiliar, high-pressure contexts is the true final test of your mastery. As you look at the complex digital systems you interact with every single day, start asking yourself, when they inevitably break, or when they are forced to change, which of those 4 maintenance chisels will the developers need to pick up? Keep chipping away at those massive blocks of ideas, and eventually, I promise you, your masterpiece will emerge. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.